A single AA battery holds about 3 watt-hours of energy, but it isn't stored as electricity at all. Almost everyone pictures a battery like a tiny tank, pre-filled with electricity, waiting to be let out through a wire. That picture is wrong. There is no electricity sitting inside a battery before you use it. What's actually trapped in there is a chemical reaction, loaded and ready, refusing to fire until you give a path. Let's crack one open and see what's really going on. Strip away the plastic wrapper, and a battery is really just two different chemicals kept apart, both of them desperate to trade electrons with each other. One material wants to dump electrons. The other wants to grab them. Left alone in a jar, they'd react instantly and uselessly, releasing their energy as a bit of heat and nothing else. A battery's whole design is a trick to stop that shortcut and force the electrons to take the long way around, through your flashlight, your phone, your car. Here's the version most of us walked away with. A battery is a container of electricity, like a bottle of water, and using it just lets the electricity pour out until the bottle's empty. It's a tidy image, and it's flat wrong. Electricity isn't a substance that gets stored and poured. What's stored is potential, chemical potential, locked into the arrangement of two different materials. Nothing is full of electrons waiting to spill. The energy lives in the chemistry, not in some hidden electrical reservoir. Pop a battery open carefully, and you'd find 3 parts. 2 electrodes, made of different materials, one that gives up electrons easily and one that grabs them eagerly. And between them, an electrolyte, a paste or liquid that lets charged atoms called ions drift through it, but blocks electrons completely. That electrolyte is the whole trick. It's a wall for electrons and a highway for ions, and that mismatch is exactly what forces the energy to travel outside the battery instead of just fizzling out inside it. Different battery chemistries just swap in different materials for those electrodes: zinc and manganese dioxide in an alkaline cell, lithium compound in your phone, but the wall and highway trick stays the same. Close the circuit, screw the battery into a flashlight, and the reaction finally gets to happen. At one electrode, atoms give up electrons into the metal. Those electrons can't cross the electrolyte, so they're stuck unless there's a wire outside offering an escape route. They rush out through that wire, through your light bulb or your phone circuit board, doing useful work along the way, and arrive at the other electrode, where different atoms are hungry to absorb them. Meanwhile, inside the battery, ions drift the opposite way through the electrolyte, keeping the whole system electrically balanced. Electrons take the outside path through the wire. Ions take the inside path through the electrolyte. Neither one can take the other's route. That's not an accident. It's the entire design. The reaction only proceeds as fast as electrons can escape through your device, which is exactly why a battery delivers a slow, steady stream of power instead of dumping all its energy in one instant burst. And this is the part that flips everything. In a rechargeable battery, that whole reaction can run backward. Plug it into a charger, and outside electricity shoves electrons back the way they came, forcing the chemistry to rebuild the 2 electrodes into their original, energy-loaded state. You're not refilling a tank of electricity. You're reloading a chemical reaction, resetting the spring, so it can discharge all over again tomorrow. Charge and discharge are the same reaction, just running in opposite directions. Push it backward too fast or too far, past the point the chemistry can safely reset, and that's exactly why chargers limit both the voltage and the current instead of just blasting electrons in as fast as possible. So a battery was never a jar of stored electricity. It's 2 chemicals kept apart on purpose, wired so their reaction can only happen through your device, one controlled trickle of electrons at a time. Simple materials, one clever wall in the middle, and a rule that turns a wasted reaction into portable power. That's the whole trick. If you'll never look at a battery the same way again, that's the whole point of this channel. Stick around, we keep cutting things open.